All right, practice problem 1.6. We're back in millimeters, grams, and seconds. Part's origin is indicated, so pretty much bottom center. But based on this, I'm going to make some choices. And one of the reasons why I want to make these optional too for assignments is these are introductory concepts that what I see, how I see it, where I'm going to make mistakes, where are the things, the frustrations are going to show up, and the fixes and corrections for them. So when they say the part is symmetric, this being the right plane, the bottom is lying in the front plane, and the top plane kind of goes through maybe probably the two circles. Yeah, it looks pretty close. Um, so when we're picking orientation, and again, orientation is really only going to be critical if we're doing a center of mass. For the volume or the mass calculation, really not that big of a deal. The other thing of note will be when we take this into a drawing, we take this into an assembly, they don't really care either, what position it's drawn in. Draw it the way that you see it in your mind's eye, the way that you can comprehend it in your brain, and get it into the geometry, and we'll worry about things like orientation later. But I am going to start a sketch on the right plane, and I'm going to draw this view first because this geometry is fairly easy. I think I can just pick the front plane or the bottom of the part, and it will just pop up from there. And they're telling to use lines, rectangles, and circles. We'll throw in a sketch fillet there as well. So we'll see what we get. All right, so part millimeter, we're going into the right plane, open up the sketch, and the only thing that really is different about this um, is the geometry. So since we're doing contours and regions, let's go ahead and start with the base. And even if I don't generate geometry from this base, I can still utilize it later. So it doesn't look like I got a coincident or anything, just the vertical. So I'm going to make that a midpoint. My dimensions then come in at 30. And the height of that somewhere is 5. Okay, so what that does give me then is the 15-degree angle up to the arc. All right, so at some point you will want to transition from the line to an arc. We can certainly come up and select tangent arc, but a quick tool is that if I start to draw a line, and sometime you will do this accidentally whether you intend to or not, you drag back over close to the start point, the end point of the line, and it transitions to arc for you. So we're able to bring that around, and I'll go ahead and make that tangent, and it will kind of drop off there somewhere, and then by escaping or selecting out of it, I can drag those out. So it doesn't look like much here. In fact, it looks pretty bad. So I'm going to go ahead. Any two non-parallel lines are going to generate my angle. So we have the the adjacent, all right, we have all of the angles available as we move around the circle. So there is my 15 degrees. The diameter here is 25. So in this case, yeah, it probably would have been a little bit better to draw the circle. Yeah, I don't know. I'm not convinced. I'll stay with what I put in. So let's switch that over to diameter though. So again, right-clicking on it, left-clicking will give you the radius and the diameter. Now I can double-click, 25. That gives me the geometry, and the center to the base goes to 40. All right, so that pulls it in a little bit closer, and then would make the assumption, just from what I'm seeing, that this line and this line end up being parallel. So let's scroll the property manager down a little bit, and we go parallel. All right, so for the fun of it, let's go ahead and put in another center point arc. And one of the only places to really get to use co-radial, so I'll go ahead and mention it, is co-radial is if you have an existing feature and you want to extend geometry, but within the sketch, very rarely will you use co-radial. The circles, a circle on top of a circle, sharing the same radius, the same diameter, those just create duplicate entities. But two arcs, if we select Control Select, we have this thing co-radial that we can come back and work from. So I'm complicating this a little bit, but I definitely want to introduce the concept. So let's go to a tangent arc, and we're going to come off of that and back there, and come off of that and go back to there. All right, so now that I have those two arcs, we're into select control select mode. So select the arc, control select the line, tell it it's tangent. Select, control select, tangent. And then are those, radius of 2 is typical, so that means we find those are going to be equal, and then we can apply the dimension 2 point. All right, so oh, they threw a good one in there. After I made it co-radial, it is not. So make sure you glance back at the drawing every once in a while, and don't do like I do. But it does bring up, more good examples of bad examples. So let me escape out of that, and we need to identify the co-radial and take that off, because that one goes to 14 and adjusts. All right, so whatever's pivoting in there gets a little bit of clearance to from our 12.5 millimeter and a half of to 14 millimeter and a half of clearance. All right, so we want to go to an 8 millimeter through. And now we have enough geometry that I think I can be dangerous. All right, so we're going to extrude. Now I don't want to do calculations, so we can go midplane, and we're going to, what did we have for a thickness? Let's do the preliminary geometry first. Actually, it shouldn't really matter which one I go to first. So let's do the 18, and then I will pick the base, because I think visually that will make more sense. And then we'll go ahead and accept. Make sure to expand out our little arrow next to the feature. Select the sketch, and we're going to extrude again. And then that one goes to 9. Make sure you are merging the results so that they do not become separate solid bodies. And then for this, I'm just going to go back into the front plane, and we'll pick up our sketch. All right, and actually I would like to see that sketch, because I want to drive this geometry. So is it going to give me the midpoint? So it found the midpoint, and it should find coincident as well. All right, so this went defined with the endpoint still in blue. We have an overall of 60. 30 is already defined in the sketch, so I'm minimizing how much I really need. And what did we have for radiuses? Radiuses of 8, so we go into the fillet and put the 8. And since that dimension's already there, we'll see what it does for the midpoint. All right, so typically we would just pick the points, but since I happen to grab the line, it is a good illustration that you can pick between two lines. And if you have two lines that are close, maybe we left that gap that we don't have a vertex established, then we can go back and cause it to generate that or calculate that fillet without. All right, so what it's telling me is since I already have the midpoint relation and the dimension, it's saying, possibly overriding that that relation. But I'm not too worried about it because I'm adding fillets all the way around, so that all looks pretty good. And then the last one will be to draw the circles, and we'll go center point, select, control select, horizontal, select, control select, equal, and then between the two, perimeter to perimeter is 40. All right, and then the diameter was back to 8. All right, so I did not get a I did not get a mirror. We need to do one more from the origin to 20. All right, now that looks okay. One thing that the volume probably wouldn't tell us on this, since we're removing the same amount of material in the same areas, is it would probably still allow me to, oh, I didn't want to get out of that. It would probably still give me an answer, but what would shift is the center of mass. Those inertias would change this a little bit. So I get out of this. It's a good time to talk about you exit a sketch accidentally, you want to get back into it, you can left click and edit sketch. I did enough to rename edit sketch, or right click and edit sketch. But I have geometry, so I can go right into the extrude. All right, let's just go ahead and pick the sketch then. And here's another endpoint. If we go up to vertex, I can pick that sketch geometry. Or if I didn't have that sketch shown, then I could go up to surface and it would stop at that geometry. So anything that helps us with the calculation, building that geometry up. All right, so let's go ahead and save this P1-6. And we'll do the mass properties. So they have 24,032. Let's see if I'm on a run here. All right, so 24,098. All right, close enough. I'm not gonna pick it up too much. I will probably take another check of all my dimensions that I have, but I think that's good.